Alright guys, in this video we are going to begin our discussion of intermolecular forces. Up until now we've spent a lot of time talking about the forces that are in operation within a molecule, right? Namely this idea of a covalent bond, sharing of electrons. We've talked about this quantum mechanical orbital concept, and we've built these concepts up through the last couple chapters actually to have a pretty thorough understanding of the forces that hold atoms together in a molecule. In this topic of today's lecture, when we're looking at intermolecular forces, what we're going to be doing is looking at the forces that hold different molecules together. Now, these are obviously very important. Right? When we're talking, whether we're talking about a crystal system, drug compounds, molecules in a liquid phase, or even complex biomolecular structures in the human body, for example, these intermolecular forces, these forces between different molecules, are going to be very important to understand if we're going to be able to understand the behavior of these bulk matter. Okay, so the first distinction that I want to make here is really drawing out explicitly what we mean by intra versus intermolecular forces. Okay, so as the little prefix here implies, intramolecular forces refer to forces operating within a molecule. All right, so this is, just as I said, the forces that are at play in the context of, for example, covalent bond where two electrons are being shared, right? Or within a molecule. So basically we're defining that molecule as that covalently bound collection of atoms, and the covalent bonds themselves are the intramolecular forces holding those atoms together. Okay, now compare that to intermolecular forces. These are the forces that are in operation between separate molecules. So in this example here, we have two H2 molecules, right, covalently bound together, the two hydrogen atoms in each molecule. And what we're going to be talking about in the context of intermolecular forces are these forces in operation between the distinct molecules themselves. Now, there's a number of very important distinctions to make, in regards to the differences between intra and intermolecular forces. And one of the most important ones for our conversation here is the difference in relative strength of these two interactions. Covalent bonds, intramolecular forces, are typically very strong compared to the intermolecular forces, the forces in operation between the two molecules, which are relatively weak. All right, so there is a very large difference in terms of the energetics of these interactions. But I want you guys to all remember that the origin of both intra and intermolecular forces are fundamentally electrostatic in nature. Remember, at the end of the day, we've got a collection of protons, neutrons, and electrons, positively charged, negatively charged particles that are coming together and interacting with one another in a variety of different ways. Okay, so it's all boiling down to electrostatics at the end of the day, right? We're just making distinctions between these two types of interactions to help us better understand the behavior of ultimately solids and liquids. And that's one of the main directions we're going to be moving to in this chapter and the chapter to come. So to kind of lay the foundation for our discussion of intermolecular forces, what we're going to do is broadly classify the different types of intermolecular forces, intermolecular interactions, into four categories. Now, it's important to know that there are more categories than this that are present, and I'll mention these as we move along, but these are going to be the four main ones that I want you guys to be very familiar with. I want you to be able to basically understand the ins and outs of. Right, so the first one on the list is charge-charge interactions. This is actually something that we have some experience with. We'll start talking about this one first. Basically, if you have a negatively charged and positively charged ion in close proximity, then there's going to be an attraction between those two ions, right? And that really is the foundation of this charge-charge interaction. Dipole-dipole interaction is going to be our next topic. In this case, rather than dealing with actual formal charges, we're going to be dealing with situations where you have a separation or asymmetric distribution of charges. And so we remember in our previous lectures, we talked about this concept of polar molecules and dipole moments. And what we're going to be talking about here is basically the interaction between two different molecules that both have a net dipole moment. Our third topic is going to be something that is perhaps quite new for many of you. It's going to be a discussion of a concept called hydrogen bonding, which at first glance is going to look a little bit like the dipole-dipole interaction, but there's going to be a lot of important differences and extensions of the dipole-dipole interaction concept that give hydrogen bonding a very unique role in a variety of different contexts that we'll explore in a lecture to come here shortly. And then finally, we're going to round out our discussion of intramolecular forces with a discussion of dispersion forces, or so-called London dispersion forces. Okay, and so basically what we're going to be doing in terms of learning objectives for this section of content here is, we want to be able to, of course, identify these key characteristics of these four main classifications of intermolecular forces. We're actually going to want to be able to rank them in terms of relative energies, which I have written here in order of increasing energy, if you want to go from bottom to top. And what we want to be able to do is use this information to be able to determine, looking at a molecule, what the dominant intermolecular force is, and then use that to predict trends in boiling points and melting points. So basically, I could give you a couple molecules, and you want to be able to use the content that we're going to be talking about here shortly to basically predict which one of those molecules would have a higher boiling point or a higher melting point, and which one would have a lower. Okay, so with that said, let's go ahead and jump into our discussion of charge-charge and dipole-dipole interactions in our next video.